This question is from the GATE Physics paper 2020. This is a MCQ type question having 2 marks, and the topic of the question is solid state physics. Specifically, this question was asked from the chapter lattice vibration. The question is, consider a two-dimensional crystal with 3 atoms in the basis. The number of allowed optical branches, that is n, and the acoustic branches, the number of acoustic branches is m, due to the lattice vibrations are. So there are 4 options given. The value of n equals to 2 and m equals to 4. Option B, value of n equals to 3 and value of m equals to 3. Option C, value of n equals to 4 and value of m equals to 2. And the last option, option D, the value of n equals to 1 and the value of m equals to 5. So let us see how to solve this problem. Now let us discuss the number of phonon branches in a solid. Let the number of atoms in the primitive cell of the solid is p. So basically the number of bases in the primitive cell is p. Now let us follow this chart. For one dimension, the total number of phonon branch will be p, where p is the number of bases. Now in one dimension only one acoustic branch is possible, so the remaining phonon will be in optical branch. So number of optical branch phonon will be p minus 1. Now for two dimension, total number of phonon branch will be 2 times p, where p is the number of bases. So basically we have to multiply the dimensionality of the system with the number of bases. So total branch will be 2p in 2 dimension. In 2 dimension only 2 acoustic branch is possible in either x or y direction. So the remaining number of phonons in the optical branch will be 2p minus 2. In 3 dimension, the total number of phonon branch will be 3 times p. So acoustic branch phonon will be 3. So basically the acoustic branch number of acoustic branch phonon is depends on the dimensionality of the system. So it will be 3 here. So number of optical branch phonon that will be remaining phonon branch, that will be 3p minus 3. Now it is given that the given crystal is 2 dimensional with the number of bases is 3, that is p equals to 3, and the dimensionality of the system is 2. So total number of phonon branch will be 2 times 3, that will be 6. As it is 2 dimensional system, so number of acoustic branch will be m equals to 2. So remaining phonon branch will be in the optical branch, so that will be number of optical branch n equals to 6 minus 2 equals to 4. So this set n comma m is basically 4 comma 2 in our case. So option C is correct. So the number of allowed optical branches and the acoustic branches for this 2-dimensional system, crystal system with 3 atoms in the basis is 4 comma 2. So option C is correct for this question.